All right, let's dive into one of the most powerful tools in your entire algebra toolkit, Vertex Form. We're going to see how this one little equation is basically the ultimate shortcut to understanding, graphing, and even creating your own parabolas in just a fraction of the time.
You know the drill, right? You get a quadratic equation, and you just sigh. Because you know you have to make that big table, plug in a bunch of x values, and just plot point after tedious point to get that curve. I mean, sure, it works, but wow, is it slow. There has to be a better way.
Well, there is. What if you could just glance at an equation and instantly know the most important part of the parabola, its absolute peak or valley, and know exactly what its shape is? That, my friends, is the magic of Vertex Form. It's not just some random formula. It's literally the blueprint for any parabola.
I want you to think of this formula like a control panel for your parabola. Every single piece of it is a knob or a lever that lets you tweak and control exactly what the graph is going to look like. So let's pop the hood and see what each of these controls actually does.
And here it is. Looks pretty simple, right? F of x equals a times the quantity x minus h squared plus k. This little formula holds all the secrets. And the three key players we need to master are a, h, and k.
So first up is a. This is our shape and direction controller. It's super straightforward. If a is a positive number, your parabola is like a happy face. It opens up. If a is negative, it's a frowny face, opening down. And the size of a, that matters too. A big number, like a 5 or a negative 10, stretches it vertically, making it really skinny. And a little fraction, like 1/2, squishes it down, making it nice and wide.
Okay, now for h and k. This pair right here, this is the jackpot. These two values literally just hand you the coordinates of the vertex, the exact turning point of your parabola. H tells you how far to shift it left or right, and K tells you how far to shift it up or down. And hey, here's a little bonus. You get the axis of symmetry for free. It's just that vertical line x equals h. Simple as that.
Okay, enough theory. That's all great, but let's actually see how this works in practice. We're going to put our new toolkit to work and start with just identifying the key parts, and then we'll actually build an equation from scratch. Check this out. We've got y equals -2 times x plus 3 squared minus 4. To find our vertex, we just need h and k. Now, here's the one thing you have to remember. For h, you flip the sign. Since we see a +3 inside those parentheses, our h is actually -3. For k, you just keep the sign, so it's -4. And just like that, bam, we know the vertex is at -3, -4. No tables, no plotting points, done.
Now let's try graphing y equals x minus 1 squared plus 3. First step, find that vertex. It's right there in the equation. H is 1, k is 3. So we go plot the point 1, 3. Now, since our a value is just a 1, we can use that simple step pattern. From the vertex, you go over 1, up 1. Go back to the vertex, go over 2, up 4. You mirror those points on the other side, connect the dots, and you've got a perfect parabola. It's that fast.
We can even work backwards, which is really cool. So say we know the vertex is at 3, 2, and we know the parabola goes through some other point like 5, 10. We can actually build the entire equation. First, you plug in h and k, so you have y equals a times x minus 3 squared plus 2. Then you just use that other point as your x and y to solve for that last missing piece, a. A little algebra later, and we find a is 2. So the final equation is y equals 2 times x minus 3 squared plus 2.
Now this form is incredibly powerful, but like with any cool tool, there are a couple of really common, easy to fall for traps. So let's make sure you can spot them and just step right around them every single time.
Okay, listen up, because this is the #1 mistake I see people make time and time again. That number inside the parentheses with the x, it feels counterintuitive. Because the formula itself has a minus sign, x minus h, you always have to take the opposite of what you see. So if you see x plus 5, h is -5. If you see x minus 2, h is plus 2. Just burn this into your brain. Inside is opposite. Say it with me. Inside is opposite.
And another thing, please, please, please do not get this mixed up with standard form, ax squared plus bx plus c. They are two totally different ways of looking at the same thing. Vertex form has that dead giveaway, the parentheses being squared. You can't just pick the vertex out of standard form the same way, so keep them separate in your mind.
So right about now you might be thinking, okay, that's a neat math trick, I guess, but where on earth am I ever going to use this? And the answer is, well, It's pretty much all around us, especially in some really cool places you might not expect.
Yeah, this isn't just about getting a good grade on your next algebra test. The exact logic, the same exact formula we just went through, is literally what powers the physics engines in some of the most popular video games ever made.
Think about a game like Angry Birds. When a game developer designs that level, they don't have to simulate complex physics over and over. They can just decide, okay, how high do I want this bird to fly? They pick the peak height, and that is our vertex. The game engine then just uses the Vertex Form equation to draw that perfect, predictable arc every single time.
So let's bring it all home. The main takeaway here is that Vertex Form isn't just another thing to memorize for a test. You should think of it like a descriptive code. It lets you read the story of a parabola, where its peak is, which way it's facing, how wide it is, instantly, just by looking at it. So I'll leave you with this final thought. Now that you know the code, now that you can see and decode these parabolas, where else do you see them? I mean, look around. The path of a basketball as it goes for a swish? The shape of a satellite dish? The arc of water shooting out of a fountain? Once you know what to look for, you start seeing it absolutely everywhere.